In this video, we are going to talk about the binomial distribution. In the last video, we talked about the Bernoulli distribution, and these are related, but the only difference is that n, so your number of trials here, must be greater than 1. So everything pretty much stays the same, but instead of saying Bernoulli, you say binomial. You have x number of successes. Remember, this x part is always dot, comma. And then you have your number of trials and the probability of success. And this is represented in the function in this form. So your f of x, success, n and p, equals nx, your combinations of nxx. So the probability of succeeding is everything else stays the same, n minus x. So what we do here essentially is looking at the experiment, but in this way. The number of trials is also fixed. The number of successes is a random variable. So let's say a coin, you're going to flip a coin 20 times. Remember, instead of just one, like the Bernoulli distribution, here it's not 1, but needs to be greater than 1. Not equal to 1, because that will be a Bernoulli distribution, needs to be greater than 1. So in our specific case here, a Bernoulli distribution is a distribution where you have n that is greater than 1. What this means for us in math, let's say you have a situation like you throw a coin 20 times. So this is 20, 14. This is the number of successes that you're looking for to obtain. The probability of throwing a coin, you have two options. You either get a heads or you get a tails, so it's 50%. And this is x, remember, this is the probability of succeeding. And now you have the probability of failing. So it's 1 minus 50%, so this is the other way around. And then you have 20, so the number of trials minus the number of successes. In our specific case, if you want to do the math, it's 0.1762. So you have 17.62% chance of, if you flip a coin 20 times, you get a 17.62% of obtaining heads exactly 14 times.